The True Phantom is a 48-volt dual current source. The standard Phantom is a 48 dual voltage source. And the difference is that current sources don't load the microphone and voltage sources are a load for the microphone and consequently give distortion. These are two schematics of phantom powering. The left one is the standard and the right one is the true phantom powering. At the left side you see at the bottom the output of the two emitter followers in the microphone. Then you see the wire and then you connect your microphone to the preamp with two 6K8 resistors and the 48 volt. This is the standard situation. At the right side you see the same output, the same cable and the same 6K8 resistors, and they have a voltage regulated current source. Their output is 48 volt, but the difference of the left side is that they don't load the microphone. They are very high impedance voltage sources. This is a schematic of a standard condenser microphone and the cable and then the input of the microphone preamp. At one you see the capsule and then the input FET. It works also as a phase shifter, and then you have the T2 and T3. They work as impedance transformers, and then it goes in the cable and you connect him to the microphone preamp. There are the 6K8 resistors and the 48 volts for the phantom power, and then you have the DC block capacitors and you have the input resistors of the preamp, in this case 1K. In the previous picture you saw that the 6K8 resistor is in parallel with the 1K resistor for audio. The total resistance then comes at 872 ohms. If you compare that with the true phantom, the 6K8 resistor is gone, and then the input impedance is 999 in the true phantom situation. This difference of load of the standard and the true phantom has a big influence on the distortion products of the output of the microphone. For 100 millivolt input, the standard phantom distorts minus 100 dB. With the true phantom, the distortion is minus 104 dB. At 200 millivolts, the distortion products are minus 88 decibel, and for the true phantom minus 92 decibel. At 300 millivolts, the distortion products for the standard are -75 and -79 for the true phantom. This is a frequency scan of the output of a microphone at 100 millivolts, and you see the signal at 1000 Hertz in the middle is the big spike, and then at 2000 there's a little distortion. At 3000 there is a even stronger distortion. Because of the not symmetric situation of the phantom power, it produces odd harmonics, and so the third, the fifth, and the seventh harmonic are produced in the phantom power resistors, unfortunately. When you use the true phantom as phantom power, the distortion products are significantly lower. The second harmonic is lower, but especially the third one, the third harmonic, is lower than it was with the standard phantom. At 200 millivolts, the products are even stronger. You see the second harmonic, and you see the third harmonic is quite strong at 200 millivolts for the standard phantom. With the true phantom, they are significantly lower at an input of 200 millivolts. At 300 millivolts input, they are really big. The second is still there. The third is really audible, and the fifth is also there. With the true phantom, there is a significant reduction of third and fifth harmonic distortions. Once more, the differences between the standard and the true phantom. This is 300 millivolts with the standard. This is with the true phantom, a significant reduction of distortion products. Here you see a graph of the distortion at different voltages of input, from 1 millivolt up to 1000 millivolts. And clearly you see at the right side that the difference at the higher inputs is about 4 dB, and that the differences at lower millivolts is bigger. When there is only 10 millivolt input, there is a difference of 10 to 13 dB between the standard and the true. And this is the reason why the ambient sound of recordings is so good with the true phantom, that are weak signals, and then the difference is even stronger than at higher inputs. Here you see the noise contribution of the different systems from 10 Hertz up to 50 Hertz, 50,000 Hertz. You see the blue line is a standard phantom power, a good phantom power remarkable amount of hiss producing, and the True Phantom significantly lower in noise. This is a graph that indicates the slightly louder performing of the True Phantom, and secondly it indicates that the True Phantom roll off of the lowest tones is later. The tones are better linearity of the low tones than the P48. What is the effect on the sound? So the True Phantom gives 4 improvements over the standard Phantom. Number 1, less distortion. Number 2, less noise. Number 3, a fraction louder. And number 4, improved linearity of the lowest tones. This altogether gives the effect that the sound source appears to be closer. And there is more ambient sound because of the lower noise floor and the lower distortion at low volumes. There are no disadvantages of the chip, except the price.